Hello everyone, it's November 22nd. Alright, let's do this. Well, first of all, I started the upgrade of React Native 2.70. Lord, is this gonna be a long day. Long day. It's gonna be a long work. A lot needs to be done. I mean, I just kind of redid the so the goal is not to just copy and paste everything from the previous version, the previous 0.65, right? I don't want to copy and paste everything. I want to basically reconfigure it. I mean, I have the source code, so I don't have to rewrite the app, but I do have to reconfigure, let's say, to get Firebase to work. And that is a lot of trouble to get Firebase to work. So basically, yeah, that one I have to reconfigure. The maps have to reconfigure, and eventually the most dreading thing is to reconfigure the fast lane, all those fast lane shenanigans. Man, I don't even want to think about it. It's going to be so bad. Lord. Yeah, I just realized something. The char is different. Can we even use the same one for publishing? We might not even be able to. I don't know. Oh, seriously, I have no idea. I do remember, like, if you lose something, then you cannot redo it. But we haven't lost anything. Something to consider down the line. Yeah, I do remember, because they only allow you to publish like once under one kind of account or some code. I think it's the signing, some type of signing. They only allow you to do it once. I don't know, man. No idea. We'll see. We'll see. All right, so what we have today. Determine if it's valid. Sudoku. Only the filled cells need to be validated according to the following rules. Oh, this is an easier one. It's not asking to solve it. It's just to validate it. So each row must contain a digit 1 to 9 without repetition. Column must contain 1 to 9 without repetition. And each of the 9 3 by 3 contain 1 to 9 without repetition. It is not necessarily solvable. Yeah, so it's not hard. Basically, we just check the rows, check the columns, check each 3 by 3. So the difficulty will be, row and columns are easy to do. The difficult one to do is difficult thing to do is to find a way to get 3 by 3. Well, actually, it's not that hard to do. 3 by 3, you just focus on the top left. Yep, this is not difficult. Oh, we can get this done. All right, let's see how fast we can get this done. Oh. All right, so we're gonna say check roles. How do you check roles then? If there's a repeat, right? So we say for I in range 9, and then for each row we're gonna go j to the end, right? Then we say what's that? Scene. For j in range 9. If board ij is in scene, return false. Otherwise, scene.add board ij. Right, so let's check rows, then check columns. J is here, I is here, same thing. And the last one, check 3 by 3. I mean, we can actually how about j? J is the same thing, right? Say for I in range 0 to 9, 3. So 0, 3, 0, 3, 6, right? For j in range, same thing, 0, 9, 3. Okay, so this is the top left. Then we're just gonna go through this. How do we go through this? So scene is set. Okay. Then can say dij. Yeah, we can say dij. We can say for I range I to I plus 3. Right, for jj in range j and then j plus 3. If board I and jj scene to false, add something like this. Oof. You know what? Screw this. I am testing this locally. Why doesn't test it here? What? That is interesting. First one. Must be at the end. Oh no! What? How is that possible? Oh, I know why. Dot. My God. What should I do? Yep. A lot of methods. Oh, 2018. What is this? This seems to be a very fast method. Bit masking. Bit masking. Oh, we got a mask. And we check the row. Check the row. Okay. So what it's trying to say is we're at here, and every time we hit, we can move 3. That makes sense. And then we get a row, and then a column. This is like the first column, second column, doesn't matter. I see. Then we just need to know which. Oh, I see what the bit masking does. Okay, bit masking is pretty smart. Okay, solution 2, we're gonna do bit masking. Okay, this one is from the previous. Straightforward. O(n) squared. Now this one got bit masking. So this is from the solution in the previous 2021. This is the solution from the solution in 2021, August 21st, 20th. The idea is to use bit masking to represent the state of each row, column, and 3x3, right? Then for each newly encountered value, we check the previous mask on row, column, and 3 by 3. If current value has been encountered before, we return false. Okay. So how do we do this bin masking? Yeah, we're gonna do columns, rows, columns, 3 by 3. TBT, 3 by 3. How should I? Square. We'll call it TBT. Okay, row, column, and TBT, right? This is going through every single one. So for every single one, we check row. Check row and then update row. Right? So I say mask is going to be one left shift int if board ij is equal to dot continue board ij. Okay, that's the mask. Then we say if row I and mask return false, and then row I all equals to mask. And then we do exactly the same thing. Right, and then this one will be column. Oopsie doodie. Column. This mask is universal. Okay, that's column. And check 3 by 3. And then update TBT. Okay, so we just need to know the index, right? Index equal to what? So given any ij, do we know which index it is? Well, yeah, it's gonna be I divided by 3, right? Because I have 0, 1, 2, 3, 4, 5, right? So that will be that. And then this need to times 3. Because if it's 0, 1, 2, 3. Right, so this need to times 3 plus j to 3. So if here is 0, that would be j. If this is going to be 3 plus 0, 1, 2, 3. Yeah, so that's the index. Then we say tbt index. Right, if and mask turn false, otherwise tbt index or equal to mask. And then return true at the end. Alright, let's try this one. Yeah. Hey, got it wrong. Okay, that is unexpected. If anything is wrong, now I suspect it's this one. What did I go wrong? Man, I don't want to draw this. That's ridiculously. It is not fun. Okay, what do you have? Five. 6, 4, 2, 3. Oh, we have a double 5. How was this not identify the double 5? Oh, I see. This is J. Oh, that's a slight mistake. There we go. Okay, done. Alright, let's try this one. Design a food rating system. Design a food rating system that can do the following. Modify the rating of a food item listed in the system. Return the highest rated food item for the type of cuisine. Food ratings. Initialize the system. We have foods, cuisines, and ratings. Food items described as of which we have length n. Food I is the name. Cuisines is the cuisine of the item. Food rating is that. Change rating. Oh, this is actually like a design, system design. Well, I shouldn't say system design. Just design a simple. It is system design, but it's a very simple system. Change the rating of the food item with the name food. So we change food into a new rating. Then returns the name of the food item that has the highest rating for the given type of cuisine. If there's a tie, return the item with the lexicographically smaller name. String X is... Oh, that's fine. So, food ratings. Highest rated. Kimchi, miso, Korean, Japan, Greek ratings. And then, highest rated cuisine. So, given Korea, we shall return kimchi. Japan shall return sour ramen. Sushi and 16. Japan 16. And Japanese is 16. Nice. Okay. All strings in food are distinct. Food will be the name of a food item across all calls. Cuisine will be the type of cuisine of at least one food item in the system across all calls. Alright, so it's gonna be heap. We just need to design it, right? I mean, what we can do is because we're given the food, right, and the cuisine, and then when we change the rating is the food, And then we query for cuisine. Damn, man. And the highest rating is within that cuisine, right? So if we put cuisine as the key, and then we have the ratings. We have rating and name and food, right? This is what we can do. And then we can heapify this. Change rating. Change rating. Okay. Change rating, basically food, but which food do you know which cuisine it is? You don't know, so we need another map to map food to cuisine. Oh, we don't need to map food to cuisine. No, we do need to map food to cuisine. Okay, we'll map food to cuisine. That's fine. So when we go there, we know which heap to modify. And food, and then we have a new rating. I mean, what we can do is also put into a tick. Yeah, we can put in a tick. We can say the first one is going to be rating, right? It's going to be rating, max heap on rating, and then a min heap on food name, and then a max heap on the time tick, a time tick. So the ones rated later will always pop up to the front. No. That's actually not true because you need to pop. Interesting. How do you know that it has been updated? The current rating. Yeah, we do the current rating. If the current rating is not the same, then we just pop. Which means we need to have food to its cuisine and to its current rating. Right? Oh man. I mean, we can use a list for that, which is fine. Okay. So hold on. We need to source. You know what? I mean, let me reopen this. Yeah, I kind of redid homebrew today, so. There we go. Alrighty. Oh, we don't have to test this. Good. We do have to import heap queue. Okay, so we're gonna say food map. Right? And cuisine heap. Okay, I'm gonna say for FCR in zip foods, cuisines, ratings. Food map food will equal to cuisine and a rating. Maybe default dict will be a better. Yeah, I think I'll use default dict. Get a list. This will be cuisine, right? Dot append. Append what? Well, it's gonna be rating, but we want highest rating, and then food. So blah blah blah. Once we're done, then we say for heap in self dot cuisine heap dot values. Okay. I say heap q dot heapify. Actually, you know what? We don't have to. We can do it here. Heap q dot heap push. Something like that. So change rating, right? Change rating will be self dot food map food 1 new rating, and heap q dot heap push self dot cuisine heap self dot food map food 0 minus new rating and food, right? So that's that. And then we say while self dot this one cuisine cuisine 0 was the top 0 1 is food. Oh my god. I'll go out true. Food equals this. Actually no, that's the rating. I'm gonna say it's minus rating. Negative rating and food equals cuisine top, right? Then we say if minus negative rating is not equal to self dot food map food 1, then heap q dot heap pop self dot cuisine heap cuisine, else when return self dot cuisine return food, right? If it's not equal to, which means it's the old rating, then we will pop the top, then we keep going again. Okay. Only have one example. Try it. Okay. not bad. That's pretty standard practice, I would say. So this is a typical problem with dynamic heap. Now, I used to have a system for dynamic heap where I keep track of each heap item in a separate list or dictionary. And each time when some value changes, I change it in that list or dict, and then call heapify on the actual heap. Now, this works, but most of the time it is slow. The standard method to handle dynamic heap is to keep pushing new items, not new, updated items to the heap, but keep a record of the most up-to-date signature of the item. Then, when we need to query the heap, we check the signature in the heap against the signature outside, against the up-to-date signature. If the two do not match, then the top of heap is outdated and should be popped. In this problem, the signature is the rating. The up-to-date signature is stored in self.full map. Right, and let's say on login for change rating, on for highest rated. Okay, I don't think there's too much to say. 3 maps. Erase, insert. What's this begin? It's the first thing, right? So creating rating. That's just a map. Wait, is this a... Does this... Is this a heap? No, it's just an unordered map. No, it's a set. Insert, insert, insert. We erase. And we insert. How do you keep them? How do you keep it? Set stores in sorted order. What? Ordered set. Is this an order set? Wait, C++ has order set? Or is by default is ordered? Oh, it's ordered. Damn. Okay. Begin to the beginning. That makes sense. Yeah, it's the same. All right. Well, I don't need to check other solutions. It's all the same. I think heap is a better solution for this. I mean, here could have done a little bit better. And the naming could be a little bit better. But yeah, it is what it is. What's the hint? Yes. Ordered set. Yeah, they all say ordered set. I guess it's standard practice to use ordered set. But it's not standard practice in Python. Oh, wow. Let's do this next time. All right, I'll see you guys.